Hello and welcome back. Today we are going to take advantage that we have assembled this gaggle of early personal computers for a photo shoot for a CNN documentary. The occasion is Bill Gates' release of his book about his youth and his early steps into computing, which led to the formation of Microsoft and was heavily influenced by these machines. CNN's documentary and interview of Gates is scheduled to air on Sunday, February 23rd at 8 p.m. Eastern and Pacific time, so if you get this in time, don't forget to tune in and see the whole story. But I'll give you a short summary so you can appreciate what we're about to demonstrate. I had the opportunity to see Bill Gates in person during his recent interview at the Computer History Museum. He told us about his first encounter with a computer while at Lakeside High School in Seattle with his buddy Paul Allen. They had access to a mainframe computer through the ASR 33 teletype terminals you see here. That's how Bill learned about BASIC and resolved to write his own BASIC interpreter one day. Later, while still in high school, the pair managed to get remote access to a PDP-10 that had been leased by a nearby startup. The PDP-10, of which we demonstrated a scale reproduction in the previous video, was an extremely powerful computer for its time. A few years later, Bill would be again working on a PDP-10 while at Harvard, and finally wrote a BASIC interpreter for it. But the PDP-10 was, like most computers of its day, enormously expensive, a financial barrier that limited computer access to a select few. But that was soon about to change. In 1975, Popular Electronics described a revolutionary small machine available as a kit that you could build for a mere $400. That was the MIT's Altair 8800, enabled by the new and revolutionary Intel 8080 microprocessor. It was one of the very first practical microcomputers, a category so new that didn't have a name for it yet. Paul and Bill quickly decided to adapt Bill's PDP-10 BASIC to the newfangled Intel-based machine. They flew to Albuquerque, Arizona, where they demonstrated their product to Ed Roberts, the creator of the Altair and owner of the small MITS company. It worked. Ed was impressed. Paul was hired by MITS while Bill dropped out of Harvard and formed what would become Microsoft, with its offices next to MITS and the BASIC he wrote as its first product. CNN is going to have a documentary about Bill Gates and his book, and they asked us to bring up these machines to come and film them and give us some demos. And the most important of them is arguably the Altair 8800, which got announced in January 1975. The machine became available as a kit shortly afterwards, and that's the one that convinced Bill Gates and Paul Allen to write a BASIC for it and commercialize it, and that was the start of Microsoft. Now I should mention that apart from my ASR 33, all those machines are not mine. They are on loan from Eric Klein, who is a renowned collector over here and also organizes VCF West, the Vintage Computing Festival in California. So thank you, Eric, for loaning us all your machines. So a couple of important things about the Altair 8800. Of course, the fact that it was announced as a kit, but the important breakthrough was the price. You could build a BASIC system starting at $400 a piece. The system was enabled by another important advance in computing, which is the Intel 8080 chip. So here at the bottom you have Intel's 4004 processor, Intel's first 4-bit microprocessor. Above is the 8-bit 8008, which is a different architecture entirely. And then finally the 8080, the first really successful 8-bit microprocessor, conceived as a general-purpose microprocessor from the get-go. Unlike the 4004 that was meant for the BusyCom calculator and the 8008, which was developed to emulate the DataPoint 2000 terminal TTL-based processor and ended up never used in SATA terminal because it was too slow. So the 8080 is really a big step here. So this is a tricked out Altair. If I open it up, you will recognize a the 8080 processor right here. So there's a processor board, a couple of memory boards. Initially, it's, you know, if you had a few K, 4K or 8K, it would be considered a lot. This one has 3 times 16 cards, so it has 48K of memory, which is an ocean. The maximum it could address being 64. We have a serial card. That's the one that's going to enable us to talk to a terminal, which causes all kind of problems. And this one is super tricked out. It has the later floppy disk drive cards, which would allow you to interface with an 8-inch floppy disk. And the nice things about the Altair is the really nice blinking light front panel, which allowed you as a hobbyist to interact with the machine without the need for another support machine. At this time, you would program it on a much bigger machine, cross-compile, and then burn a PROM and then run your program on the target system. This one is a self-contained target system. You can, very difficultly, but it can be done. You can paddle in little programs directly on the machine, needing no extra support. Of course, the famous S100 bus, it turns out that it was standardized on the 100-pin connector because Altair got a good deal on those connectors. The important consequence of that is that the bus became sort of a de facto standard and that you could buy later card to add to your system. So we spent a lot of time dealing with the serial card from hell, which also you would build as a kit and had the wires of the Wazoo. This is cleaned up. When I got that one, it has all kinds of wires everywhere and it wasn't working. So the first thing you have to do is get this to talk to that. So when I first got the machine, I got the difficult problem of getting my ASR33 to talk to this, and we had some hardware problem, but after I solved that, we needed a way to test them. And that's when I had to get familiar with this little machine, which actually I came to like pretty much. The front panel is really well done. So first, for those that don't know, to reset it, you have to do stop and reset. Here we go. And then you have the basic is the data, and 8-bit of data and 60-bit of addresses. Some control signals from the processor, which are useful to when you debug your program to step through. Wait light and hold light, which the machine abuses to display the content of the processor. So I'm going to load my little test program. I reinvented the wheel, but it was a good exercise to figure it out. So the freaking serial card doesn't work before you initialize the chip, which is kind of annoying. You cannot test it easily. So the first instruction will do just that. So we're going to put in 7/6 in octal. That's, so you see the 3 bits at the bit 1, bit 2, bit wait 4. So that's a 7. That's a 6. So that's a load immediate, and I'm going to load the value of 3 that I'm going to put in the next memory address. So now I'm in memory address 1, I have put 3, and then I do an out instruction, which is going to send the 3 to the card, which is at address 20. And that will do the reset of the chip, after which we have to tell it partially at which speed to work. So we do another 7/6. Now the value that we need to load is 21, which in combination with my wire will make it talk at 110 bauds, and the write on 8 bits. And then we do another 3 to send it to the card address 20. And then I'll keep going doing that, and I'll do a little, so it's a little loopback program. So it interrogates the port 20, and then it checks 346 is it's an AND with 1, so it just read the status bit. If the first bit of status is 0, that would be this, So that's a jump if 0, and I jump back to address 10. All right, 0010, which since it's a big endian is 1000. And then if we go through the loop, we're going to read this time for address 21, which should be the data. And we are going to spit it right back with an out on the same port 21. And then we are going to jump back, that's a 303 at address 10, 0010, which is entered as 1000. And let me check if I got that correct. Then we do a reset. Then we start over here, get this online, run it, and find out that it doesn't work. Well, there's something wrong. It's because we moved the computer and we disconnected it. All right. See if it works any better. Am I still running? Yeah. By the way, when it runs, you don't see much on the data, but you see the addresses. So it's looping right now within the range that I defined. Oh, there you go. So I'm reading characters and printing them back. It's just an echo loop, which means I have been able to connect those two together. Yeah. It's somewhat interesting to single step through it, by the way. Let's try that actually. We can stop it. And then we are at 10. So that's great. That's the beginning of our little loop. Let's put a character. Let's put an A in there. And then let's do single step. So reads from address from port 21. And then it read the status byte, and when this one is on, that's the one we're going to test, it means there is a character waiting because I just typed it. Then that's the 346 instruction. That's the AND with data 1. And oh, that's the jump if 0, 312 to 1000, and it won't do the jump, it will continue. So here I'm at address 16. And I should continue. Yeah, I went to address 17, so I didn't jump, which is correct. Then I'm going to read my byte on address 25, and there it is. It read it, and it's an A. It's 101 in octal. Then it's going to do an out instruction on port 21, and it should come out. It did not. Interesting. Oh, it did. Okay, because I had to go through the instruction, and then it's the branch back to 10. So we went through the little loop. So that's how you debug your programs when you're stuck, man. I did a lot of that. So now that we have the two talking together, the next step is to recreate Bill Gates' first product, which was basic for the Altair, on a paper tape, on a punch paper tape.
Flashback.
Guys, I'm trying to run Microsoft Basic on an Altair 8080, and it's way more difficult than I thought. So this is Bill Gates' first product, right? And this is the smaller version of it, and it's going to make a big pile of tape on the floor. So fortunately, you would normally not have to do this. You would just buy the punch tape from Microsoft or from MITS, really. The tape would have been punched on a much more expensive high-speed punch, not on my little ASR33, which is not the right machine to punch long binary tapes, and is going to shake itself to bits. Whoa, it has finally stopped. It took forever. Right, I'll break. I'll just have to wind it. There you go. Right, we punch our little tape. This is the smallest version of basic 4K, could run into 4K memory. It's also the fastest to load. The 8K and the extended, they take forever. They take 15 minutes to load, so I'm not going to take you through that. And then I have made my very special box of Microsoft goodness to put my spool of tape in there. Let's try that. All right. Let's see here. We put our spool of Paul Allen and Bill's goodness in there. All right. Now to read it and put in memory, you need to write a little program, because this machine right now is running my echo code, so that it won't do anything. And for that, Paul and Bill wrote you a little bootloader program that you have to paddle in. So excuse me for a minute, I will paddle in the historical bootloader. Okay, I did it. And what this is basically doing, it took me a while to reverse engineer it because it's made to be very, very terse, so they use non-logical stuff to save a few bytes. But it initializes the card so it can talk to the teletype. Then it looks for 302, and 302 is what is on the leader of the tape. The whole tape has a whole beginning bunch of 302s. I'll show you later. This is my bunch of 302s. 302, and that's the leader. And when it's not 302 anymore, it starts to go and pick the bytes from the tape and put them in memory. And at the end of that, after 302 bytes, actually, 302 is the marker of the leader and also the number of bytes that have to be loaded. That is the checksum bootloader. So we have the simple bootloader here. Then it loads in memory the checksum bootloader, which is more complicated, would have been too painful to load by hand. And then loads the basic from the checksum bootloader, which is much more advanced and checks for the integrity of the data. So we're good now. We should try to run this. So we start this. We do run. And it's in the 302s, and you can tell it's running my little program in low memory. And once when it has taken the checksum loader, it will run a different pattern from higher memory. So here's the checksum loader. And we wait for the 302 bytes. Oh, that's so good. It gave me something and it shouldn't. Okay, so it doesn't work. What happened? Not an unusual occurrence. It might have gotten a bad bit, but it should remain entirely silent. There is no reason it should give me an error character. I might have paddled something with a mistake in it. It might have gotten a bad byte. I spent so much time making sure the reader read error-free. Okay, give me a second so I check the computer and reset it again. Alright, let's try this again. I had to re-enter my bootloader because it had written some garbage over it. Try this. this time. So we wait like this for, I think, 8 minutes. And we're waiting for a response from BASIC. Okay, so that's good. When you hear the glung 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 glung, it means it loaded correctly. I can see the pattern here of the LED is running BASIC. So let's see what it told us. It's hard to tell because it's hidden here, but what it told us is memory size. It's asking you for how much memory you have in your machine. We agreed to answer a return on that one, so it takes the maximum memory available, and while I do that, I'll put you a little further away. So it's going to go through all the memory until it finds that there is no more. And you're going to see that on the lights over there. So I do return, and you can see getting memory. And now it's asking terminal width, and since it was made to work with this terminal, which is 72 column, I have to do nothing. That's the default. I do return. And then it asks me if I want sine. And at this point it's concerned with my memory and asks me if I really want sine and cosine, but I have plenty of memory, so I say yes. And here we go. 45,000 bytes free, 4K basic 4.0, copyright mix 1976. But before we get too excited, I need to clean up my big mess. So now that we have Microsoft's BASIC loaded, we have a much more powerful and usable system, so we can do any BASIC directive. Print hello from Bill. There you go. And it almost printed it correctly, except I had a mechanical error in the teletype. It had a trouble. It printed Eljo. Mistaken a J for an L. Not enough oil in the computer. All right. But more generally, what you do is you develop a program. You punch it on your tape by listing it. And here's a tape that I already punched. And I'm just going to load it, and it's basically automated typing, so it will type the program. Okay, it's a little for next loop that prints 10 lines and a few lines before, a few lines after. So now we're going to run it. So I'll type run. And it has printed my 10 lines. It made a mechanical error right here. It's line 6 instead of line 6, and said, "Well done, Mr. Gates." It's indeed very well done. So just to make this clear, the various typing errors you see are not computer errors. It's a mechanical teletype typo. The teletype decodes the serial bits mechanically, using a diabolical system that we explained while we restored it. I must have a sticky lever. Needs more oil. Running it one more time from here so we can see the blinking lights. Run. voila. I mean, you had to be quite a visionary to realize that this meant a revolution in computing and that this was going to be the future. And that, it did become the future, and here are a few personal computers that all run Microsoft Basic. You have a PET Commodore at the back, you have a TRS-80, and actually, if I start it up, you recognize the Microsoft Basics. It asks memory size. And you have, of course, the Apple II, which has Microsoft Basics inside. It was actually quite a feat to write such a program. Bill wrote it personally, and he was a very good programmer. And it was so good that he was dominant in the basic market for the first few years. Nobody could write one as good as he did. So here you go. It's a little lesson in history, and don't forget to watch the Bill Gates episode on CNN coming up this Sunday. See you then.